Can you see my screen okay?
Yep.
All good, cool. All right, yeah, thank you very much. So my name is John Saltanovitz. I am a stream restoration engineer working with EGLE in our Wetlands, Lakes, and Streams unit based out of Lansing. I assist in a lot of culvert review projects, stream restoration projects, bank stabilization projects throughout the state, which involves a lot of bankfull identification in the process. Bethany, do you want to introduce yourself?
Sure. Hi, I'm Bethany Matusik. I also work for EGLE in the Water Resources Division in our Wetlands, Lakes, and Streams unit. And I'm one of our two stream specialists. And my focus area is kind of on bankfull stream mitigation. So providing technical assistance to staff all across the state regarding permit applications that have stream alterations and stream impacts that might rise to the level of needing stream mitigation, and working on designing and reviewing designs for stream mitigation projects and the Michigan SQT.
Great. All right, so let's get going. So again, this is Bankfull Training 2025. What we're going to talk about today, we're going to break it up into 4 sections. We're going to first talk about what Bankfull is and why it's important. We're going to talk about what to do before going out for a field visit. We're going to talk about what to do during a field visit. And then at the end, we're going to talk about how to verify Bankfull. One thing I do want to note is that at the end of each of these sections, we're going to take a quick break to answer questions. So we want you to ask questions as things come up. We want this to be an interactive webinar. So if you have something, that's fresh in your mind while I'm presenting, please put your questions in the chat. Bethany is going to be monitoring that. And then after each of these sections specifically, we'll answer some of those questions instead of saving them all until the end. So again, encourage you to ask questions as they come up, because we want this to be interactive. So section 1, what is Bankfull and why is it important? So I'll start off first with the definition of Bankfull. Bankfull is the elevation where floodwaters will fill the channel and just begin to overflow onto the floodplain. In other words, our channel banks are full. It's in this situation that we're triggering maximum deposition and erosion circulation cell development. In other words, our sediment is moving effectively. So as I mentioned, it's the point where water will fill the channel and access the floodplain. So in this situation, our Bankfull, when it's full, it's not currently in this photo, it's going to be approximately right here. Now we're going to get into the indicators later. Don't freak out if you don't understand how I picked out Bankfull. This is just a representation to show where Bankfull is in a channel that's well connected to its floodplain. So some more Bankfull definitions. Bankfull flow is the flow responsible for moving the most sediment and maintaining channel form. That's from Dunn and Leopold of 1978. It's considered the most effective or channel forming flow. You're going to hear me say that a lot today, channel forming flow. So I apologize if it gets repetitive, but it is a very important part of what Bankfull is. This is why Bankfull flow width is the minimum structure width required for simulating and maintaining form and functions through a crossing, such as a bridge or a culvert road stream crossing. If we were going to correlate Bankfull flow to a storm event, it's typically on average going to be your 1.5-year storm event. Now, this can vary depending on where you are in the country. It can be anywhere from a 1-year event to a 2-year event. It can depend a lot on your watershed conditions, your land cover. However, for the sake of simplicity, we like to say on average, it's about a 1.5-year storm event. So this is a graphic that we like to use here a lot at EGLE. If you've seen presentations of ours before, you might be somewhat familiar with this, but if you're not, I'm about to explain it. So What this graphic shows is it plots sediment transport rate, storm event frequency, and the product of those two compared to discharge. So if you look on this x-axis, it's showing discharge as it increases from left to right. So I'll start first with this red solid line. That's our sediment transport rate. So obviously, as we get to a higher discharge, we're going to be moving more sediment. Now, this black dashed line is our storm frequency line. So obviously, as our discharge increases, those frequency events, like our 100-year storm events, aren't going to happen as often, but that's where you're going to see a higher discharge. Now, this red dashed line is the product of the sediment transport rate and this frequency line. And you'll notice there's a point where it peaks and then begins to drop back down. That peak is what we like to consider bankfull. It's our effective discharge. The most effective discharge is going to be the one that occurs, again, between that 1 and 2 year flow. It's not the one that's happening, during our largest events. It's going to be the one that's happening more frequently, that's moving sediment more frequently. A lot of times we like to think that our channel forming flows are large, 50-year, 100-year storms, which they will impact the stream, but the storm event that's actually going to more frequently form our channel is going to be this one that's happening more frequently. And it's because at these storm events, the stream bottom is picking itself up, moving and redistributing itself in the same riffle and pool patterns that existed prior to the bankfull discharge. And this is all taken from Roskin in 1996. He's done a lot of the stream restoration work throughout the country. You might have heard of his name before. So let's talk a little bit about bankfull field indicators. So bankfull field indicators are physical evidence of the location of the water surface at the bankfull discharge. When we're looking for indicators, we want to make sure we're looking for them at appropriate locations and at appropriate times. So some locations that we might want to look for bankfull are on the inside of our bends, on point bars, on our banks. We want to be looking away from structures that could be influencing our channel, such as culverts. And we also want to make sure we're not looking for bankfull during really high flow. If you go out to a site and it had a historic rain event 2 days prior, that water may be currently above where bankfull is. So if you go out to a site, you could be unintentionally thinking bankfull is a lot higher than it is if you go after a historic rain event. It's also good to know the recent flood and drought history of the area to avoid being misled. Like I just mentioned, if we have a really high flow event recently, one bankfull indicator that we'll get into is sediment deposition. If you're seeing a lot of sediment deposition really up high and there's just a 20-year storm event, that could mislead you into thinking that, oh, bankfull is, way up high. But the reality is, if you know that that rain event just happened, you may know that you're being misled with that bankfull indicator. On the opposite end of it, if it's been a drought recently, you might see a lot of vegetation in your channel and think that bankfull is actually lower than it is. So just having the knowledge about the history of that area prior to going out to a site is really important. When we are looking for bankfull field indicators, we want to use multiple indicators wherever possible. If you have 2 or 3 indicators that are all matching a similar elevation, then that's a good sign that you're on the right path to identifying bankfull correctly. And we always want to verify our field-determined bankfull stage using multiple lines of evidence. So let's talk about some common bankfull indicators. Some of our primary indicators that we're going to be looking for are changes in bank slope. This is basically just showing where water is beginning to flow onto a floodplain. We're going to be looking for deposition and depositional features, as I mentioned, such things such as silt, sand, debris, woody rack lines, point bars, and small benches. We're also going to look for a change in particle size, as maybe the particles are moving from a coarser material within your channel to a finer material on the floodplain. Some of our second Secondary indicators that we're going to look for are scour lines, such as exposed roots. And then we're also going to look for a vegetation line, more so the absence of woody or perennial vegetation. So here's a photo. I've not labeled Bankfull yet on this. I will here in a second. Take a look at what you're seeing. Look for some of those indicators that I just mentioned on the previous slide, and kind of in your mind, point to where you think Bankfull is. I'm just going to give like a couple seconds here. So if you thought Bankfull was right here, you're correct. And let's dive into why we're making that Bankfull call. So the first thing we're seeing is sparse annual vegetation. That was one of the indicators we talked about. This is a point bar. So as I mentioned, when we're looking for Bankfull in specific locations, a point bar is a good location to look for. Also a point bar that's developed. The top of that point bar is a good indicator. We're seeing a change in slope here. That's showing that the water is getting out and onto the floodplain, causing that change in slope. This is a depositional flat, so we're seeing finer sediment. And then we're seeing the particle size change from a coarser material within your channel to a finer material on the floodplain. And you can pretty clearly see that where that arrow is pointing to right there. So here's another example. I already kind of labeled where Bankfull is here. Again, on the left bank, looking downstream, we're seeing the top of a point bar. So we're looking at a good location to identify Bankfull, and we're seeing that change in slope on that point bar. Now on the opposite side, this is an indicator that we didn't have in the previous photo. We're seeing a scour line forming. Typically those scour lines are going to form where water at Bankfull isn't actually able to get up and out onto a floodplain. So that scour line's forming, and it's hard to tell in this photo, but there's also a lack of vegetation there. And what's great about this example is we have two different indicators on different sides of the bank that are matching up to show the same Bankfull elevation. Here's another example. So in this scenario, what I'm looking at from a Bankfull indicator standpoint is while I am seeing a change in slope, kind of where we're seeing our shoes up here, I also am noticing a change in slope a little bit closer to the water. In addition to that, I'm seeing a scour line and lack of vegetation, where in this situation, I would call Bankfull approximately right there. This is a channel that's been historically downcut over time and dredged. In this situation, you know, our Bankfull is not going to be high up on our top of the terrace. It's actually going to be a little bit lower. What I'm seeing here is I'm seeing a change in our bank slopes on our right side. So Bankfull is going to be approximately right here. And I do want to note, when I previously said that the definition of Bankfull is where the channel fills and begins to access our floodplain, that is true in historically unaltered streams, or where the stream is able to access its floodplain. However, as we know in Michigan and all throughout the country, we have a lot of degraded streams that have been impacted. In those streams that have downcut and aren't able to access its floodplain, it's still going to form Bankfull indicators. It's just the definition doesn't fully apply in these scenarios. Bankfull is still happening at that same flow. It's just not able to access the floodplain in a degraded system. So here's another example on a golf course. What I'm seeing in this photo is I'm seeing a change in our bank slopes. Lack of vegetation is tricky here because it's been actively managed, but I'm also seeing what we call a mid-channel bar. These are bars that'll form in the middle of our channels as opposed to a point bar on the inner bend of a channel. So I'm seeing that mid-channel bar right here, which is matching up really well with our change in bank slope right there. So that would be approximately our Bankfull elevation. I kind of touched on degraded channels already, but oftentimes in our degraded channels, we're going to see the stream start to build its own floodplain bench within that downcut channel. And when that happens, our Bankfull is going to be typically on the back side of that bench where those arrows are pointing towards. And again, this is happening in our incised or historically over widened channels. So here's the situation again where the stream has downcut over time. We've had a lot of instances where people may think that Bankfull is actually up here, higher up on our terrace where the floodplain used to be. However, this is downcut over time. So when we look at the indicators here, we're seeing a bench that's starting to form on both the left and right bank to still provide some energy dissipation during those Bankfull flows. So our Bankfull is going to be approximately right here. This is another historically over widened and downcut channel. Again, we're seeing that stream is starting to try and form Bankfull benches where our Bankfull is going to be where those two blue lines are. This is the same site, just another vantage point where we're seeing the bar development on both the right and left banks. The channel isn't able to get up and out onto its relic floodplain, kind of where you're seeing the crop production. So it's forming our benches within, and our Bankfull is going to be approximately right here. So again, I just want to note that these benches are typically going to be indicators that you see in historically over widened or downcut channels. If you're in a wetland, specifically like a sedge wetland where you're going to see a lot of sedge hummocks, our Bankfull is going to be the lowest elevation between those sedge hummocks, kind of in that low depressional point. So these are just some bullet points of why Bankfull is important. You know, if you leave this webinar, I think these are some important things to take away for why we really stress Bankfull. Again, it's our channel forming flow. It's the most effective sediment transport, as I mentioned earlier with that graphic we were discussing. It helps to provide energy dissipation and erosion reduction. So when our water is able to get out onto the floodplain in a channel that has a stable Bankfull, when that water gets up and out, it's no longer eating at the banks and circulating around the banks, causing erosion. So when we have channels that are properly sized to Bankfull, it just helps to provide energy dissipation. As that water is getting up and out onto the floodplain, it's also improving our riparian health and potentially adjacent wetlands that may be present by raising the water table. Also, the deposition of that water getting up and out on the floodplain can be really helpful for any nutrients that may be in the system. And then lastly, Bankfull is really important for geomorphic stability. If we're having effective sediment transport and our system's in balance, we're going to see a lot of riffle and pool features, which I'll discuss a little bit later in this webinar if you're unfamiliar with what those are. But they're essentially just geomorphic features within our stream that are very valuable to a lot of stream processes and aquatic organism habitats. So why is this important from a regulatory standpoint? Appropriately sized Bankfull and supporting rationale are going to be required in a variety of permit applications. I will note that if you are submitting a permit application and you're providing Bankfull sizing, we really stress that you provide any cross sections that you may have collected, provide any photos that you took of your cross sections, provide photos that you took of your Bankfull indicators. And then if you're also going to utilize calculations to find Bankfull, which we'll get into, we want you to provide those as well. Even if the project is elevated above a minor permit category, Bankfull should still be properly measured and incorporated into appropriate projects as a best management practice. Sizing Bankfull correctly will help to avoid and minimize impacts. So in Michigan, here are just some of the permit categories where you're typically going to see Bankfull incorporated. For GPs, we're talking about clear span bridges, a lot of county drain projects, smaller culverts and bridges. And then in our minor permits, we're talking a lot about bioengineering practices, county drains, larger culverts and bridges, and then fish and wildlife habitat structures. These aren't the only categories where Bankfull is going to be required. It's just these are the most typical that we tend to see them get brought up. From a regulatory standpoint, it's also important to touch on the difference between Bankfull and ordinary high water mark. So Bankfull are features that are tied to a specific reoccurring flow, as I mentioned, that 1.5 year flow. However, ordinary high water mark is going to be lower than our Bankfull elevation. The stream energy is usually going to be lower at our ordinary high water mark. It's not going to be our channel forming flow. And ordinary high water mark is more of our regulatory line. Whereas Bankfull is going to be our line that's associated again with that 1.5 year flow, and it's our basis for natural channel dimensions. So in that graphic there, you can kind of see Bankfull is where that red line is, and ordinary high water mark is our yellow line, kind of closer to our base flow. And lastly, too, I just want to touch on, from a regulatory standpoint, the definition of a stream, because we're really only going to be talking about Bankfull when we're talking about 301 regulated streams. So what we're looking at when we're defining a stream is a river, stream, creek, drain, or any other body of water that has defined banks, a bed, and then visible evidence of continued flow or continued occurrence of flow. This includes the St. Mary's, St. Clair, and Detroit rivers. Feature may or may not be serving as a drain as defined by the Drain Code of 1956. And changes to definitions of WOTUS do not affect Michigan statute on the definition of a stream. So again, Bankfull will only come into play when we're talking about regulated streams. Lastly, in our general conditions, if you were to go to our permit website and look at our GPs and MPs, at the bottom, there's a general conditions category that discusses Bankfull a little bit and the order of preference. All this is saying is that when you're going out and you're determining Bankfull for a potential permit application, we have an order of preference for how we want it to be determined. So our first order of preference is that you're going out into the field using on-site indicators to determine what Bankfull is. The second is going to be using our regional curves or any other calculations that are similar to the regional curve to calculate what Bankfull is, and we're going to dive into that. And then lastly, if you're not able to find good indicators on site, or for whatever reason you don't think the curve is reliable where you're doing your project, you can model it for a 1.5 year flow, not a 2 year flow. We're looking at a 1.5 year flow to kind of help determine where a Bankfull indicator is going to be. So that's section one. I'll take a quick pause. Bethany, did we have any questions in the chat from this first section?
We haven't yet. I don't see any questions having been typed into the Q&A. This is your opportunity, folks. If you have any questions about what John just talked about that you'd like to get answered at this time, go ahead and type them into the Q&A. And please, at any time, if you think of a question, go ahead and type it in there. We can look at them. There'll be another spot where we'll stop and pause for questions. And then again at the end, we'll make sure that we get all the questions answered if there are any. I don't see any, John. So.
I do have a question. I can ask a question, I guess, if it's okay.
Yeah.
So with determining Bankfull width and, considering ordinary high water mark, where would you kind of demarcate the boundary of like where a wetland starts versus like what would be regulated under part 303 versus 301? Would you use Bankfull width or would you use the ordinary high water mark? Because like in some of those instances, you showed kind of a bench where it had wetland associated with that fringe along the streams. Maybe this is not your expertise, but I guess it was just like a permitting question.
So ordinary high water mark is the regulatory boundary for Part 301. So we would look at, I suppose we would look at anything outside of that boundary as if there were wetlands there as being regulated by 303. And then anything that is then within that ordinary high water mark would be regulated under Part 301.
Okay, that makes sense. Okay, thank you.
All right, well, we can keep moving on. And again, please put in any questions as we're moving through. I know this is a lot of information, so we don't want you to feel overwhelmed at all at any point. I always like to say there's no stupid questions except the ones that you don't ask. So Section 2, what do we want to do before we go on a field visit? So there's going to be 3 things that we're going to want to do before you go out to a field visit where you know you're going to want to determine Bankfull. First, you're going to want to find your drainage area in square miles. We're going to discuss a little bit about drainage area versus our contributing drainage area. We're then going to want to enter our drainage area into the regional curves. And then lastly, you're going to want to review aerial photos of the site prior to going out. So now I'm going to dive into kind of each of these 3 topics to explain them a little bit more. So there's 2 options that I'm going to discuss for finding your drainage area. The option 1, the first thing you're going to want to do is you're going to find your site on Wetlands Map Viewer. You're going to check for a hydraulic studies unit or HSU flow point under other data on Wetlands Map Viewer. It's currently not there right now. That's why it's shown in red. Map Viewer is going through some updates, and I believe when it's all done, those flow points will show back up. But there's still a way to do this despite that. I just have that in red for right now as a caveat that for this presentation specifically, we're not going to be seeing that on Wetlands Map Viewer. And then lastly, you're going to go to EGLE Flood Discharge Database. If you just search EGLE Flood Discharge Database, it'll pop up. You're going to enter your county, hit submit, and then you're going to look for the HSU flow point or a nearby flow point, and then click on that study and make note of the drainage area that's within that study information. And I'm going to show this example here to kind of better explain what I just discussed. So option 1, this is going to be for Fleming Creek. I'm going to pull my screen over. So I'm on Wetlands Map Viewer. If you just search EGLE Wetlands Map Viewer, the interactive map, this will pop up. Typically, when I mention that there's other flow points or the HSU flow points, they would be under other data down here. However, they're not there right now. What that is when you click on the HSU flow points, it'll populate all of these points throughout the map that show where previous requests for hydraulic studies have been done. So it could give you a sense of, if we were looking at this crossing, we might see a point pop up, which to us would mean, great, someone's already requested what the drainage area is here, we can utilize that. However, if you're not seeing a flow point or if the flow points aren't working like they're not right now, it's still okay. But what I'll do is I'll just click on the site just to know what county I'm working in. If you're unfamiliar, sometimes it can load a little slow. I do know we're working in Washtenaw County. What'll happen is it'll pop up here on the left and give you like the township and the city and the county that you're working in. It should say Washtenaw. I apologize that it is processing slow right now. But if I know we're working in Washtenaw, our next step was to go to the EGLE Flood Discharge Database. Under counties, I'm going to click on Washtenaw, hit submit. I know we're working on Fleming Creek. So I would go to Fleming Creek. Sorry, I went a little bit too far. I would go to Fleming Creek and I'm going to see, there's a lot of previous studies that have been done on Fleming Creek. Now, if I had a flow point already, I would know that maybe there would be one here. If I didn't have a flow point, I could then look at where that study was done. I see Getty's Road, and I know that's where we're doing our project. So I'll just click on this study right here, and I'll see that our drainage area and contributing drainage area is 30.33 miles squared. It also will provide a lat long, so you can go back and plug in that lat long into, Google Maps or whatever map viewer you're using, just to double check that that study is for your site location. You may see a difference in our drainage area versus contributing drainage area for different studies. I will say that you should use the contributing drainage area, not the drainage area, because the contributing drainage area is going to take into account maybe some wetland sinks or detention areas that may not be all flowing to your point at the same time. So I see that our drainage area is 30.33. So I now have a drainage area before we go out to our site using option 1. So option 2, let's say you're having trouble finding a previous flow study that's been done. You can't find anything nearby. I've typically, even if I can't find anything nearby, maybe I've found one that's like a mile upstream or downstream that I can use to compare. But let's say you can't find anything in the vicinity. You can try and delineate it yourself. We've used a site called Model My Watershed. It's just modelmywatershed.org. So you'll just go to that website. You're going to then delineate your watershed. You do that by just clicking Get Started, delineate watershed. You're going to find your site location, click a point on the map, and the drainage area it's going to give you, I should know, it's going to be in square kilometers, but you're going to want to have that in square miles, because our regional curves, which we'll get into, use square miles as the entry. So let's go into that option. So I just went to model my watershed. I've already kind of zoomed in roughly on the area that we're looking at. So here's Fleming Creek right here. I just hit Get Started, and I should say it's this crossing specifically right here. I hit Click Started, delineate watershed. I'll just do the continental US from NHD Plus. Then all I have to do is click a point, and it's going to delineate my watershed. So there's the watershed that it's delineated. I'll notice up here in the top left that I got a drainage area of 79 square kilometers. I will know, just because I already did the quick calc, that comes out to 30.5 square miles. And you'll remember from what we got from the hydraulic studies point, that was 30.33. So really, really close in the approximation. So what if neither of those options I just mentioned work? If neither option works, it's likely a smaller stream. I've had trouble before delineating watersheds on Model My Watershed that are less than 1 to 2 square miles. If it's having issues, it's probably a little bit smaller. But again, this is not a guarantee. You can also delineate the watershed utilizing your own preferred methods. If you have a tool within GIS that you've set up to delineate your watersheds, or it's a smaller one and you feel you can just do it by hand, or drawing a polygon in GIS or some other software, by all means, that's perfectly fine. If you are working for EGLE, you can always ask for the drainage area in a correction request if you feel it's essential to help, understand the project. If you're a practitioner and you want to know the drainage area, you can always make a request through the EGLE Hydraulic Studies Unit as well. And those are those HSU points, again, that I was discussing. If none of this works, or maybe you just ran out of time, you can always go out into the field without knowing the drainage area. It's not the end of the world. It's just helpful as a way to prepare to get an idea of what the bankfull width may be. So what is a regional curve? Why do I bring this up? We found our drainage areas to plug into our regional curves. So a regional curve is a regression line that's been developed from reference sites where stream gauges are located or gauge data has been collected. At each of these reference sites, they collected Bankfull data, such as Bankfull width, Bankfull area, Bankfull mean depth, and Bankfull discharge. And what this curve does is it allows you to estimate these Bankfull characteristics at sites where there is no stream gauge based on the drainage area. So you can look at a site, plug in your drainage area, and it'll give you your estimated width, area, depth, and discharge based on all this previously collected data. So here are our regional reference curves from 2015. You'll see here on this graph on the left, in red is our Bankfull area, in green is the width, and I believe that's like a purple. That's our inner floodplain area. We're not going to worry about that. And then in black here is our Bankfull depth. We not shown on here is discharge. We also have an equation for that. So what this is all of those reference sites that I was discussing are plotted on this graph, and we have our Bankfull width here on depth, area is all here on the left, and on the bottom x-axis is our drainage area. So these equations are based on this best fit line through the reference data collected. So for width, for example, which is our green line, that best fit line gave us this equation. So if you knew what your drainage area was, which we've already found, you could plug it in to where it says DA. Again, that just needs to be in square miles, and that'll give you your expected width for the site that you're going to. So we like to, before we go out to a site, get an idea of what our expected width is, our expected depth, area, discharge you don't need to really worry about unless you're doing like a stream relocation restoration design project, then I would encourage it. But we also don't really need to worry about inner berm. These R-square valued will show you how well all the values are correlated from a statistics standpoint. You'll notice that all of these are pretty high outside of the depth, but it's still pretty accurate from our experience out in the field. But our width has a 0.86, area 0.96, and discharge of 0.89. So these were collected from sites in Lower Michigan. This graphic just kind of shows some of the locations they were taken from. We do want to note that there are some limitations to the curve currently. It's mainly applicable to southern Lower Peninsula, as I just showed on the previous image, and our sites that have had data collected at are all smaller than 10 square miles. So the curve is really only showing sites that are greater than 10 square miles. That doesn't mean that you can't use the curve up north or use it for sites less than 10 square miles. It's just we want to acknowledge that there are some limitations to it currently, but we are working to collect additional data to expand the curves to different parts of the state and to allow smaller drainage areas within the curves. Specifically those smaller watersheds, that's going to end up being pretty helpful. There has been data collected, as you can see on this map, in different parts of the state. It's just not enough to have, a northern Michigan curve, a UP curve, etc. So let's quickly go through just an example of how to calculate those values. So in our example, we use Fleming Creek, which had a drainage area of 30.33. So if we wanted to get an idea of what our width, depth, area, and discharge are for that site before we go out, we can take those equations, which I showed on the previous screen, and then plug in our drainage area of 30.33, and then it'll give us all of these values. So our width would expect it to be, 38.7, depth around 2 feet, area around 80.7, and our discharge around 185.14 cubic feet per second. Lastly, before you go out to a site, we want to make sure that you're looking at aerials ahead of time. to help you understand the site and see if there's anything unusual that may be occurring. Specifically, be sure to look for the following. Does the stream change as you get farther away from the culvert? Culverts can impact streams, and we'll dive into that a little bit later. You want to look to see if there's any impoundments upstream or downstream of the crossing that could be influencing your channel. Look to see if there's any tributaries flowing in nearby that could affect your flow. And then also look to see if the stream has been historically channelized or realigned to give you a sense of maybe why the stream is acting the way it is or why it's flowing the way that it is. So that's section 2. I know there's, again, a lot of information there from a regional curve standpoint and how to find your drainage area. But do we have any questions specifically on section 2 or any from section 1 that you've thought of since our last round of questions?
I haven't seen any questions yet in the Q&A, but I did, John, I have been putting links to the web pages that you've talked about, like Wetlands Map Viewer, Logic Studies Unit, Model My Watershed. I've been putting all that in the meeting chat there so everybody can have access to those links.
There's one question I see that just came in. It said, what is a HSU flood point? Is it an EGLE field verified point?
The HSU flow point it's done by our hydrologic studies unit. I wouldn't say it's field verified. It's just they will calculate the drainage area through modeling from a desktop analysis, if that makes sense.
Yeah, they have, they will also calculate all the flows. So I think typically it might be the 2-year through the 100-year flow. Is standard. So if you make a request for a point to get flood frequencies, they will give you all of those flows from the 2-year to the 100-year.
So it's based on like modeling and online desktop review?
Yes. Yes.
Okay.
Yeah. Yeah. I should.
Oh, go ahead. Sorry.
I was just going to say, I should note too, how Bethany just mentioned they'll provide the different flow events starting at the 2-year. We recognize that that's the lowest that they'll typically provide. But again, just a reminder that Bankfull is going to be 1.5. So if you're ever, using a flow study for the flow within a channel that maybe you're utilizing Bankfull for, a reminder that 2 is going to be a little bit too high. We prefer that 1.5 for what it's worth.
And the hydrologic studies unit will provide the 1.5-year flow if you request it. So if you make a request for a flood discharge, you have to special request the 1.5-year to be added on to what they would normally provide. That's all I've got, John.
Cool. All right, let's keep moving. Section 3, what to do during a field survey. So we're going to discuss the steps you need to take doing a toothpick survey. We're going to look for Bankfull indicators. We're going to measure Bankfull to water surface. We want to look at getting consistent measurements. And then finally, we're going to look at measuring our Bankfull width at riffles. So what is a toothpick survey? Toothpick survey was kind of, that term has been coined from Roskin, as I mentioned earlier. The idea is when you first get to a site, you put a toothpick in your mouth, you walk around, and you just kind of get a sense of what's going on. Highly recommend that you just get out, walk up and down your channel, your project site, wherever you are, to get a sense of what the stream is doing. You want to get out of the influence of any culverts that may be there, see how the stream's changing as you're walking up and down. You can get a idea if there are any good stable riffles that you want to survey and take your bankful measurements at. Keep an eye out for any bankful indicators that you may be seeing that we discussed earlier. And then also see if there's anything out of the ordinary occurring. You know, are there any dams or log jams that may be impacting your channel flow? So again, just kind of diving back in quickly to our bankful indicators. As you're doing that toothpick survey, you could be getting a sense of where bankful is. So in this situation, our bankful is going to be where the water is accessing the floodplain. It's well connected here. It's that change in slope that we're seeing as our indicator. But as you're walking up and down, you can kind of eyeball that and keep looking as you go. You know, in this situation, if you're walking up and down, you may see, hey, there's like a good little bar that's been forming here. I'm seeing a scour line and a little bit of a lack of vegetation. I think that may be a good bankful indicator. Now, the perspective I should note on this photo is a little weird. Those are at about the same elevation, even though that doesn't really show it in this visual. You know, if you're in an incised and deep in channel, again, as you're doing that toothpick survey, you're probably going to be looking for any bankful benches that may be forming. So you're probably going to be looking, you know, approximately right around there in this situation for bankful. So again, just things to keep an eye out as you're walking up and down. If you're not able to find any bankful indicators on site, we should note that you can always find a nearby reference reach to collect data. This could be a natural reach or a reach that's stable and has recovered from previous impacts. You know, obviously this isn't ideal. We would like you to collect data on site specifically, but we understand that sometimes sites have been previously impacted where there may not be any good bankful indicators present. In those situations, you can go upstream or downstream to find reference sites. If you can't find anything upstream or downstream, you can always find maybe a reference site nearby that's a similar drainage area or stream order. So as you're walking up and down your channel, you can start to measure your bankful elevation. To do this, you're going to need a survey rod or another straight edge, a pocket rod or a carpenter's rule, and a small bubble level. And what you can do is you can take your survey rod, place it on where you think bankful is, try and get it as level as you can using that small bubble level, and then using your pocket rod or carpenter's ruler, you can measure the distance from your water surface to that rod, that bankful to water surface difference. And what you're going to see is as you move up and downstream, that bankful to water surface measurement should be close to the same at different bankful indicators. Now, that may change depending on when you go out to a site. You know, if you go out to a site during a drought versus after a recent storm event, that bankful to water surface is going to change from one day to the next. But at the actual day that you're at the site itself, you should be able to get consistent bankful to water surface measurements as you walk up and down. So it's a good way to kind of train your eye to see where bankful is. You may see a couple indicators and you're getting maybe a measurement of bankful to water surface of 1 foot. And then there's another one where you got a measurement of 2 feet. But because you've taken a lot of measurements, you could say, well, I know that measurement's probably a little bit too high because it's not matching up with all these bankful to water surface measurements that I've already found at good indicators that I like. So when we're measuring our bankful width, we want to make sure we're measuring it in the middle of a riffle. That's because it's our narrowest part of our stream. If there aren't any riffles, let's say you're in a sand bed stream, we just encourage that you measure it still at straight runs or at least at the most narrow point of the channel. We want to avoid taking our bankful width measurements at pools or bends or the widest part of our stream. The only caveat to that is if you're doing a stream restoration project where you were going to design a pool cross section, then we would encourage you to find reference pool widths. But for the sake of culvert crossings. Most projects, we're just looking at our riffle widths. You can measure at multiple riffles just to see if you're getting any changes or if you're getting consistent measurements. We want to stay away from the influence of structures when we're measuring our widths. Stay away from culverts, bridges, outfalls, pipes, or log jams. And then use your field indicators. If none are available, let's say you go to a section and you really like that riffle, but you're not seeing great field indicators, you can use your Bankfull to water surface that maybe you've already captured at different areas at your project to figure out where you want to measure Bankfull at. So if you're not familiar with what a riffle and pool is, so here on this top graphic, our riffles are going to be where you're going to see your slope change. That change in grade is typically associated with riffles. They're shallower, more narrow, where our pools are going to be our flatter sections. If you're looking at it from a top-down view, our riffles, again, are going to be in our narrow sections. Our pools are going to typically be on our outer bends. When you're going to take these measurements, this is just another graphic that kind of shows areas to avoid. Starting near the road here, you'll see that this culvert has caused some scouring, some aggradation. We wouldn't want to measure our width here because you'll notice as we get farther away from the culvert, our width is changing. We want to measure it at our riffle cross sections, these little yellow lines, once we get out of the influence of this road. So why don't we want to really measure anything near a culvert? I know oftentimes when we get to sites, oftentimes we're parking near a road stream crossing because it provides easier access. However, while I know it can be a pain to have to walk a little bit more, getting out of the influence of that culvert is going to get you a more stable and accurate Bankfull width. And what happens is oftentimes those culverts that we're looking at are undersized. When those culverts are undersized on the upstream side, here on the left, it kind of blocks water from flowing effectively. And when that happens, it'll start to drop a lot of sediment. As it starts to drop a lot of sediment, it'll over widen. And then on the downstream side, because that pipe is too narrow, it'll start to scour out the downstream bed from the higher velocities and stress that are coming out of that culvert. You can see here in this profile, I'm sure everyone has seen some of these where you're at a culvert outlet and you see this big scour pool from an undersized culvert. So that's why we just really want to avoid taking any measurements near our culverts, because you can kind of be misled into what you think Bankfull may be. Now, I will say there are sites where you may have a culvert that is properly sized. However, maybe due to the culvert construction or more pedestrian access from people trying to get down to the river, we would still avoid it in those situations as much as you can. This is just like an example I like to show from like why an undersized culvert is a detriment to the stream. It's similar to when you put your thumb over the opening of a hose. Once you turn on your hose, it's going to be flowing normally, but once you reduce that opening, you restrict that water, it backs up the water within the hose, and then the water shooting out of the hose is coming out a lot faster. Similar idea can be applied to undersized culverts. This is a video that just kind of shows that in real time. This was just like a flume study that was done, but I think it's an interesting example just to kind of show how culverts can scour out stream channel beds when they're undersized. This is obviously simulating something that happens over the course of years in a couple of seconds, but it is a good visual just to show what's happening when we have those undersized culverts, and why also sizing our culverts to a properly sized Bankfull is really important. Because if we had a really small culvert, you'd see this, whereas if we had a culvert that was sized well to Bankfull, you're probably not going to see the same scour and release of sediment downstream that you're seeing here. Yeah, and it shows here just another quick example. It'll start to scour out here pretty fast. And that's what we don't want to see over time. But you'll notice a little bit farther downstream, that width is a little bit different than what you're seeing up here closer to that culvert outlet. So once you've found, your riffle, you found that spot where you want to take your actual Bankfull width, what you're going to do is you're going to pull your tape from one Bankfull indicator to the other. That should be level. If you've checked your Bankfull to water surface on each side of that tape, it should be the same. So you'll pull your tape level from each side of the bank. This is it looking from within the channel, and that's how you'll measure your width. So, just make sure again that we're looking at the proper areas to take these measurements. You're in a riffle, you're away from the influence. You've taken all those factors into account. Once you get to that point where you feel pretty confident about your Bankfull indicator, that Bankfull to water surface, the location you're taking it, then you can pull this tape and figure out what your Bankfull width is. And again, you can do this at multiple locations. This is just one photo of one location where you measured the Bankfull width. Section 3 questions.
So a question did just come in. It said, what if a crossing is proposed at a bend in a stream, or the measurements at narrow riffle sections of this, or the measurements at narrow riffle sections of the streams do not match the Bankfull width where the crossing is proposed?
So the first part, if it was being proposed at a bend, I think one thing is we would really stress alternatives to begin with in that situation. We would ask about road, realignment. Can the crossing be moved to a different location? Let's say none of that could be done. It had to be in a bend for whatever reason. We do allow alignment of the channel just upstream and downstream of the culvert to ensure that it's kind of flowing through at like a more straight angle. Let's say that was not possible either. We would probably recommend that you're sizing it to more of a pool Bankfull width. Because if you are putting in a bend, that would be your pool cross section. Our pool cross sections are typically going to be a little bit wider. So you then are going to have to probably then use a wider culvert. Now, obviously you want to try to avoid that, because if you're looking at a wider culvert than maybe you need, that might come with more cost too. So just something else to consider. What was the second part of that question?
It was just indicating what if the measurements at the riffle sections of the stream do not match the Bankfull width where the crossing is proposed. So they're basically just saying that if they're proposing at the bend and they're taking measurements at the riffle, how do you, and it sounds like you may have just answered that. Yep.
Yeah. I would just stress that you kind of look at those alternatives first, try and realign the channel if possible. And then I would look at, if you can't move it and you're not impacting the stream, you might have to oversize it. Bethany, you looked like you were maybe going to add something.
Oh, yeah. I mean, I was just going to say, I agree with you that we would first look at trying to move that crossing to where you do have a riffle. We don't typically like to have crossings at bends of streams. But I also think it's different depending on what kind of crossing you're talking about. Like if you're talking about a bridge versus if you're talking about a culvert. If it's a bridge, then that pool is going to be able to remain there. So we would want you to span that wider pool Bankfull width versus if the proposal is to put a culvert there, you're not really going to be able to maintain that pool. So probably the narrower width is okay, but but we would probably push back against locating it there in the first place.
Yep. Any other questions?
Yeah, there was a second question. So it says, would the bankful width be smaller at a deeper section of a channel? And I think they mean wider at a shallower section of the channel.
So, okay, I'm just trying to wrap my head around. So
Yeah.
it kind of depends. There's a lot of site factors that can come into play that affect your bankful width. You know, obviously our pools, our wider sections are going to be wider and deeper. Our riffle sections are going to be a little bit more narrow and shallow. Now, if you've had a site that has historically downcut over time and maybe it doesn't have access to the floodplain like it used to, we call that like a more entrenched or incised stream. That stream isn't able maybe to get out to the width that it wants to from a more stable standpoint. So it's going to be a little bit more narrow, but because it's more narrow, it'll then be maybe a little bit deeper. I am going to get into that here in this next section when I talk about bankful area. But yeah, that's tricky because it kind of depends on your site specifically.
You know, I would say that riffles are typically your shallower and narrower parts of your stream channel. But all of your bankful discharge is fitting through that cross section of that riffle. So that's your hydraulic control point for your stream channel. Your pools are typically going to be, like John said, wider and deeper. So, you know, that is just naturally how the stream functions. Is part of the way that it dissipates energy is in those wider, deeper sections on the outside of a meander bend where you typically find a pool. So yeah, I wouldn't say that just because it's shallower means it's wider.
Anything else?
Nope, that's all the questions.
Cool. All right, last section. We're just going to talk here about how to verify some of your bankful measurements that you may have measured in the field. So for verification, we're going to make sure that you're checking your field measurement to the expected regional curve value that you calculated prior to going out into the field. You know, that's how we found our drainage area. You plugged it into those equations. You found what the expected width was. Check that with what you measured in the field. If you're really far off from, you know, what the curve is expecting, you may be outside of that scatter range in the regional curve. You could be measuring bankful at the wrong indicator. I'll show it here in a second, but you know, even if you're off the curve a little bit, you may still be within the scatter range. So it's important to check those upper and lower limits of that scatter range for your bankful width or area, or, you know, whatever it is that you're measuring. If you're confident in your indicator, but your bankful width is off, one thing you can do is check your bankful area. I really like to stress that bankful width is really important, but so is bankful area. If you're unsure about the width that you're measuring, that's why, again, we emphasize taking your widths at multiple riffles. That way you can see if maybe I was just measuring my width at a riffle that was like abnormally bigger than some of the other ones on site. And remember, if you're getting a really wide bankful width that you don't want to be measuring in pools, there could be a chance that, you know, you've taken that in a pool. So with bankful area, as we kind of touched on already, bankful area is going to remain consistent during bankful flows. I like to use this example of like water in a beaker from, like, you know, middle school science class. You know, I feel like we've all have seen something like this at some point, but with different shapes even though the shape is changing, that area of the water inside that shape is remaining the same. So you're going to still consistently have the same bankful width throughout, or sorry, bankful area in your riffles throughout your project. So if something's off, you can also check your bankful area with the regional curve to see if you're off there, or if you're accurate. Let's say you're getting, a bankful width that's a little bit lower than what the curve is expecting, but you check your bankful area and you're like spot on what the curve is expecting. Maybe it's been historically altered and it has a smaller width, but you can see that your bankful area is accurate, so you know that you're probably still on the right track. So how do we want to measure a cross section if we also want to get the area? As I mentioned previously, we're going to pull our tape from bankful to bankful. Note that you should always measure left to right. I should have mentioned that earlier. And you want to take that like looking downstream. If you're going to take a photo, take it looking downstream. Check that your tape is level, and then along your tape, if you're trying to get an area estimate, you're going to take depth measurements from the bed of the channel to the tape at every significant change in your bed slope. So as you're going along, you'll take a recording of the station along the tape and what depth you measured. And this is a way to really quickly calculate your area. Now, obviously, we know that there's more accurate ways to take cross sections with GPS equipment or survey grade total stations, but for this exercise, this is a really quick way to estimate your bankful area. So here's kind of it from a visual standpoint. We've pulled our tape along the top of this yellow dashed line, and then at every change in slope, we've taken a measurement from the tape to the bed. So let's say you've done that. Here's kind of an example. Let's say you measured that your bankful width was 5 feet wide, and you took all of these depth measurements at every change in inflection point. You're getting depths ranging from 1 foot to 2.9, 2.8 feet. What you would do to estimate your area really quickly is you would sum up all of those depths and divide by your total number of measurements. You would avoid your first and last measurement, where the bankful depth would be 0. Like you're not taking a depth on the left side here and the right side over here. You're just averaging out these actual measurements that you've taken. So add all those up, divide by the total, which is 9. And in this situation, our mean depth would be 2.27. To find our area, all you have to do is multiply width times your depth, that mean depth, which would be 2.27 times 5. So you would get an estimated area of 11.35 square feet, which then you could compare to the regional curve as well to see how close you are. So again, just a quick way to do it that can be pretty helpful if you're unsure about what you're measuring. Again, here's our regional curves. Just as a reminder, this is what you want to use to, field verify some of the measurements that you've taken. These were the equations again here on the right that we are plugging all those values in. Here's the area one. Again, that has a pretty high correlation R squared value, so that's going to tend to be pretty accurate. If, let's say, you went out and you measured your width, but you're off, as I mentioned, you should check that range of scatter. So you can kind of look at the upper and lower limits of that scatter where, let's say at this 50 square mile drainage area, let's say you were measuring, something a little closer to, I think it's about 35, but the curve is expecting 50. You could say, well, I'm at 35, but within that range, I'm still like within the range of other sites that have been collected. So just because you're off doesn't mean that it's wrong. You should always check with the scatter range to kind of verify what you're getting. In a similar mindset from the bankful area, you can do that. Let's say you are at a site that's lower than 10 square miles and you want to kind of check that range. For a site that's 5 square miles or lower, you can just kind of extend those best fit lines farther downstream to check that range. So that's it for this presentation. I do want to note that, you know, we know that this was a lot of information, but Bankfull identification is really important. It is going to take a lot of time and experience to get good at, you know, identifying where it's at. I always like to say it's like learning a foreign language. You know, the more you're doing it, the better you're going to get at it. So just it takes time and practice and patience. So like, don't get frustrated if you're not seeing it right away. When I, you know, first started out learning about Bankfull, it took a while to wrap my head around it. You know, but the more I got out into the field, was looking for indicators, was working on sites, the easier it became. So that's the end for this. We can take questions now on that section, and just the entire presentation as a whole. If anyone has any lingering questions that they would like answered on this webinar specifically.
I'm not seeing anything in the chat yet, John.
Okay.
So
Um,
I'm not able to ask a question because I guess as hosting I can't, but I do have one question and maybe you answered already, but what's the significance of Bankfull area and drainage area as it relates to Bankfull width? I guess like, I understand going in the field and identifying it in field and
mhm.
measuring, but like how does that tie into the Bankfull area?
So Bankfull area is just another way that you can kind of verify that your measure, like your indicator is correct. So, you know, if you're at a riffle and you were getting something that was a lot smaller than what it was being expected from the regional curve. You know, the regional curve was expecting 20 feet and you're getting 10. That's where you can then also check your Bankfull area, because your Bankfull area may still be accurate to what the curve is expecting. Kind of how like they went out and collected reference data at all these sites for Bankfull area, mean depth, discharge, width. All of those are related then back to the drainage area. So Bankfull area is just another method that you can use to kind of check. It's also a lot of times utilized if you're doing like a stream relocation or sizing project. We would really look at what your Bankfull area is compared to what's at the site itself, because during those Bankfull flows, you know, that area is going to remain consistent. We want to make sure the channel is sized properly for your Bankfull area, because if you're oversizing your Bankfull area, you know, during Bankfull flows, your water may not be getting up and out onto the floodplain or maybe a Bankfull bench to help dissipate energy. So area is really important. It's just kind of like another part of this that is kind of associated with Bankfull width.
Yeah, I would say that, you know, your area measurement incorporates both width and depth. So, you know, if you're just looking at width, you might find yourself a little bit off from the curve. And so in order to be able to kind of verify if that width is correct, you might look also at area. Because if your width is a little bit narrower, but you've got a little bit of a deeper channel, then your area is still going to match up with the curve. Conversely, if your width is a little bit wider, but your depth is a little bit shallower, you're still maybe going to have the same area. And so it's a good double check on whether, you know, the indicator that you're seeing is accurate.
All right. Yeah, that was really helpful. Thank you.
Yeah. So I think that's it from a webinar standpoint. You know, thanks everyone for tuning in. We are going to dive into the field notes for tomorrow, but just for anyone who may be, watching this at a later point online, thanks for tuning in. Our contact info is on that previous slide if you ever have any questions about Bankfull. But yeah, thanks for listening.
Thank you
Bethany,
so
I'll
much.
let you take the field logistics part.
Yeah, okay. And Brianna, you can stop the recording there.